Hello again. You've seen how to draw a ray diagram for a convex mirror. Now let's look at something with a bit more variety. Concave mirrors. Concave means the mirror is bulging inward, just like a cave. Because it's curved, this mirror has a focus and a center of curvature. Here is the focus, labeled F. Our friend the stickman is standing to the left of F, so we say he's outside the focal distance of the mirror. I'm going to show you 3 different situations involving this mirror, because the placement of the object actually affects the nature of the image we get. This is the first case, and it's fundamentally the same process as for convex mirrors. First, draw an incident ray that goes from the top of his head parallel to the principal axis. Then, draw a reflected ray from where it hits the mirror's pole and down through the focus. There's no trickery here, just go in parallel and out through F. Now we take a second ray that goes in through the focus. This one hits the pole at an angle. Can you guess what happens when it reflects? Yep, the reflected ray goes out parallel to the axis. It intersects, or crosses over, the first reflected ray on the far left. That point of intersection is where the image appears. How can we describe this image? First of all, it's enlarged. That means it's bigger than the stickman who's checking himself out in the mirror. We can see the image is also upside down. The physics term for that is inverted. His head and his feet are reversed. And the image is real. We didn't draw any dotted lines behind the mirror. All the light rays are real, and so the image is real too. If you wanted to, you could project it onto camera film and record it forever. That was the first case, and it wasn't too hard, right? Well, now things are going to get interesting. The mirror is the same, but our stickman has moved closer to it. He's standing exactly on the focus. What difference will this make? Let's find out. Again, we draw a ray that goes in parallel to the axis and reflects out through F. That is, it passes right between his feet. But wait a minute. Doesn't the next ray go in through F and out parallel? If we try to draw an incident ray through the focus, it just goes straight down and never hits the mirror. That's not very helpful for finding an image. However, there's another ray we can use. If you draw one that hits the mirror exactly in its center, it reflects at exactly the same angle. At the very center of a curved mirror, it behaves just like a flat one. This gives us a reflected ray that goes out parallel to the first reflected ray. But if the 2 rays are parallel to each other, they'll never converge. Don't you need convergence for an image to form? That is indeed true, and this is the one case where an image is not possible. If an object is exactly on the mirror's focus, it will not have an image because the reflected rays don't converge. This only happens with concave mirrors. Now the third and final case. Our friend has moved off the focus and is now very close to that mirror. He's inside the focal length. He will have an image again, but what will it look like? Once again, we start by drawing a ray going in parallel to the axis. It reflects out through F, which is behind the stickman. If we draw a ray going in through F, again, it won't hit the mirror. So we aim a ray at its center again like this, which reflects at the angle of incidence. These rays are not parallel, but they don't seem to be converging either. What can we do? This is where those cool dotted lines come in. Trace the reflected rays back behind the mirror like this, and now you can see virtual rays that do converge. So there is an image, but because we had to draw virtual rays, it will be a virtual image. The image is clearly enlarged, as it's way taller than the stickman. It's standing on its feet, so it's now upright. And as I said, it's a virtual one. This is what you see when you hold the inside of a teaspoon really close to your face. With concave mirrors, the position of the object matters. If you move from outside the focus of a teaspoon to inside it, your image flips from being real and inverted to virtual and right way up. This behavior is totally different to what convex mirrors do. Now we've considered those 3 cases, let's see what things we learned. The image in a concave mirror can be real or virtual depending on how far away the object is. A ray incident on the exact center of a mirror reflects at an equal angle. In other words, the mirror acts like it's flat in the center. If rays reflect off parallel to each other, they won't converge even if you trace them back as virtual rays. Therefore, it's impossible to form an image. Just a reminder, make sure you draw rays so that they reflect off the pole of the mirror, not the mirror itself. The mirror is drawn just for the sake of identification. And finally, use a ruler. Wooden, plastic, steel, as long as it has a straight edge, it's your friend. Now for some exercises on mirrors and ray diagrams, where you may practice this skill. Good luck and aim high!